Good morning. Didn't know if I was going to make it to school by Monday, so I recorded this video ahead of time. If you don't have the paper from Friday, the sub should have extra copies, but I first wanted to go over the paper from Friday. So we're going to go through every problem on this paper, and then after that, I'm going to try and use a few minutes to go into solving systems by graphing, including some inequality stuff. So starting off on here, number one, we have y equals 3x minus 4 and y equals x. We can go ahead and replace the y in the first equation with x because it says x is equal to y. So using substitution property, we're going to substitute x in. So we have x is equal to 3x minus 4. Then we need to solve. So we can go ahead and subtract that 3x from both sides. So we have minus 3x minus 3x. That's going to give us 2x. Let's say negative 2x equals negative 4. Then take that 2, divide it off from both sides. So negative 2 being divided from both sides leaves us with x equals positive 2. Now, since x and y are equal, well, if you plug that into that x value, y would also be equal to 2. So again, these two are equal. Therefore, y is also equal to 2. So our coordinate point would be at 2, 2. On number 2. Now, I did this in some class periods. I didn't do it in others. It caused a lot of confusion in some of my early classes. So since both of these are set equal to y, and I'm still doing substitution property, but I can basically substitute this entire formula on the bottom and for the y value that's at the top. Because if this is equal to y, then this can replace y. So negative 2x plus 2 is equal to x minus 7. Bring this x over to the other side. Subtract x, subtract x. This gives us negative 3x plus 2 equals negative 7. We can bring the 2 over by subtracting it. So we have negative 3x equals negative 9. Divide off both sides by 3, or negative 3. And x is going to equal positive 3. Now, once we have the x value, we still need to go back and plug it in. It doesn't matter which one. I think the first one looks a little bit shorter, so I'm plugging back in for the first one. Again, 3 goes in for the x. Still have the minus 7. And 3 minus 7 is negative 4. So our answer here is at the point 3, negative 4. Alright, go to number 3. On number 3, this one is a little more like the examples that we had done in class the previous day. So this entire thing is set equal to y, therefore we can replace y in the first equation with that entire thing. So we have 7x minus 7 parentheses negative 2x plus 13 equals 14. Distribute the negative 7. So negative 7 and negative 2 multiply to give us positive 14x. 7 and 13 multiply together to give us 91. Combine like terms, 7x and 14x is 21x. You go ahead and bring this 91 over to the other side as well, so subtract that off from both sides. 14, wait. That should not be negative. Sorry, that should not be positive, that should be negative. Because we had a negative 7 times a positive 14. That should be negative 91. So we're going to add the 91 to the other side, which makes this 105. And 21 does go into 105 evenly, so again, dividing off the 21 to get x by itself, and we get 5. Once we know that x is 5, again, plug it back in. I plug into the second equation this time since it's already set equal to y. So y equals negative 2 times 5 plus 13. Well, negative 2 times 5 is 10. That's again a negative 10. Negative 10 plus 13 is 3. So y equals 3. So our corner point, 5, 3. going over to number 4. On number 4, again, bottom one set equal to y, so we can go ahead and plug in for y in that equation. So we have 9, negative 9x plus 3. Again, this y is being replaced by this entire equation. 3x plus 7 equals 21. Distribute the 3. So negative 9x plus 9x plus 7 equals 21. Well, positive 9, negative 9, those cancel out, and we get a statement that is false. Let's just double check our work real quick. Actually, I made a mistake, which I forgot to distribute that 3. So if you double check, again, most common mistake, and I saw this a lot when we were doing this worksheet on Friday, and I do it myself sometimes, forgetting to distribute. That is one of the easiest things to forget. Sometimes it's easy to forget just distributing the 3 to both parts. Also, if this had been a negative number to distribute, like it was on the last one, I forgot to distribute the negative sign at first. So again, same type of issue here. Distributed property should have distributed, and this would have been a 21. So then we have 21 equal to 21. And it's important because if this is a true statement like it is now, 21 is equal to 21, there's no variables left. This is now infinitely many solutions. If it had been a false statement like I had first wrote it, it would mean that there's no solution. So again, 2 completely different answers there, even though the 9 still canceled off. So again, this is infinitely many solutions. Infinite number of solutions is a good way of saying it. So again, that is it for number 4. Don't have to do any more work. Number 5. The first equation is going to be the easier one to set equal to y. So I'm first going to rewrite it. Y equals, we're going to add 4x to the other side to get it over. So positive 4x minus 3. So now we can take that whole thing and plug it into y for the second equation. So we have negative 8x plus 2 times, parentheses, 4x minus 3 equals negative 3. The 2 again gets distributed, so we get negative 8x plus positive ax minus 3 equals negative 3. And again, notice, if I forget to distribute on this one again, here, these cancel off, and I end up with this, which again, that makes it look like it's a true statement. But again, distributive property, don't forget to distribute that 2 to both parts, because then that means that this is not negative 3, it would be a negative 6. So when I cancel these off, negative 6 equals negative 3. That's not a true statement, so that means that there is no solution. Now, a lot of times on these problems, you'll see that if you don't do it correctly, the problem might be set up so that you get the wrong opposite answer. So if you didn't distribute to that second number, same thing happened over here. If you don't distribute to the second number, you would have got no solution. Down here, where the answer is supposed to be no solution, if you didn't distribute to the second part, you got infinite solutions. So again, just be very careful there. On number 6. This time, it's easier to set this equal to y. So, equal to x. So I'm going to take the second equation, bring the 6y over to the other side. X equals negative 6y minus 21. You could have also said x equals negative 21 minus 6y. That would also be correct. And now we're taking this entire thing and plugging it back into the first equation for x. So negative 4 times negative 6y minus 21, close parentheses, plus 3y equals negative 24. Distribute. So that's a positive 24y. That's going to be a positive 84. Oops. So we got the 3y, and it's equal to negative 24. 24y and 3y, we can go ahead and combine those. That gives us 27y. 84, we can go ahead and move that over by subtracting it. So that's going to give us, let's see, 8, 108, I think. Yep. So now, divide 108 by 27. I think that goes in evenly 4 times. So y equals 4. Now, know what y is. Oops, I'm sorry, you cannot see that one. Let's show the work again. Here it is. So again, took it, distributed. After we distributed, combined like terms, brought the 84 over to the other side, got 108, divided by 27, and y was 4. Now again, that's just y, we need x. We could plug it back into either one of these equations, or since we already solved this equation for x, plug it back into that equation. That'll also give us the correct answer. So plug in 4. That's negative 6 times 4. It's going to be negative 24. Seems really high. Did I do something wrong? Negative 6 times 4 is 24. Wait. I forgot a negative. Yep, I forgot a negative. 24 was negative. We brought this number across, and we subtracted the 84. So this was negative 108. Then when divided by 27, gave us negative 4. So I plug this in as a negative 4. So now that's positive 24. Positive 24 minus 21. Now we're no longer going to get a fraction or a decimal or any other crazy numbers. So if we add those together, or subtract them, I should say, 24 minus 21 is 3. So we have a point at 3, 4. On 27. Now we're talking about elimination. Well, this one's already nice. It's set up for us. Those 4's can cancel out when we go to add. Again, we're just adding the whole thing together. So that's 6x. This is going to be negative 6, divide off 6, and you can have negative 1 for x. And that's how fast that type of problem could be. Now we got to take that and plug it back in. Doesn't matter which one I use, I'm just going to plug it into the top. 2 times negative 1 minus 4y equals negative 18. That's negative 2. Bring the negative 2 over to the other side by adding it. So it's negative 16. Divided by negative 4. And y is positive 4. So our point is at negative 1, positive 4. Alright, on the next one. If you add these together, these cancel out. Add those together, those cancel out. So when they cancel out, it doesn't give us nothing. It gives us 0. So we added these two together. Got 0 on that side. This side we get positive 2. That's a false statement. Therefore, this is no solution. Oops. And number 9. This one is not set up anyway where they match. So we're going to have to rearrange this. We could flip the entire top equation so that this is on that side and these are on the other side, and we just have opposite values for signs. So if we had flip this, we get negative 4x equals negative 10 minus 2y. So now add these two equations together, the original bottom one and then the top one that's been changed. Combine our like terms. This is now positive 5x. This is negative 5. And these cancel out. So Divide by 5, and x is -1. For y, plug it back in. Doesn't matter which one. I'm just going to go all the way back to the original. 2y plus 10 equals 4 times -1. 4 times -1 is -4. Subtract 10, you get -14. Divide by 2, you get -7. On number 10, they're matched up, but we got to multiply one of them. So let's go ahead and multiply that bottom equation by 6. So we're going to rewrite this. First equation, not changing. Staying exactly the same. Bottom equation, we now have -6x, -12y, and 18. So these will cancel out. This gives us -18y. This gives us 36. Divide by -18, and you get -2. So that was y. Plug it back in to get x. Again, it doesn't matter which one you plug it back into. So I'm going to go bottom equation this time. -x minus 2 times -2 equals 3. -2 times -2 is a positive 4. So -x plus 4 equals 3. Subtract off the 4. You got -1. Get the negative over to the side. Becomes +1. So we got our two parts. 1 comma -2. Good for final answer. On the next one. Let me zoom out just a little hair. Alright. Number 11. Again, we don't have anything that's exact opposites, so we're going to multiply the bottom one by 2. When we do that, the bottom equation becomes 6x. Oh, that's not going to be opposite, so let's do a -2 instead. -6x minus 10y equals -4. On top, 6x plus 10y equals 4. Well, when we go to add these together, these are going to cancel. These are going to cancel. Those are going to cancel. So, everything canceled. Is that no solution? No. It's actually infinitely many. Because when all these things cancel off, again, we're adding these together. So these are still going to be 0 and 0, which is a true statement. 0 is equal to 0. So, infinite number of solutions. On number 12, again, needs some rearranging. I think I'm going to just rearrange the top one by bringing this 24 over to the other side. 6y equals, not equals. Positive 24 equals 2x. Switch those two around so they're in the same format. 2y minus 2 equals 4x. Well, the one at the bottom, I can multiply that by 3 and get the top number I needed. So, and we want it to be negative, so -3. So now I have, for this one, -6y plus 6 minus 12x. So now combine this equation and this equation. These are opposites, they'll cancel out. And it gives us 30 on this side, 2x, and negative 10x. Divide by negative 10, and you get negative 3. Once you have that, plug it back in. Negative 2 plus 2y equals 4 times negative 3. That'd be negative 12. Bring the 2 over. So add it. It's now negative 10. Divide off that 2. And we get negative 5. So negative 3, negative 5. Number 13. No, I did 14 in every class, so I don't need to go over 14. But this is kind of similar to that. We're going to have to multiply. They're in the correct format. But these aren't opposites, nor are these. I'm going to pick these two small ones. And again, I'm multiplying by the opposite coefficient. So I'm going to multiply that whole top thing by 5. This whole bottom thing by 2. So that gives us negative 10 minus 15y equals negative 5. The bottom one, again, multiplying by 2, 10x, I've got my x up there, plus 20y equals positive 5. So add those together. These cancel. These cancel. These give us 35. Divide off the 35, and you get 0. If y is 0, plug it back in, find x. So negative 2 minus 3 times 0 is negative 1. And that cancels out. This is 0, so negative 2. There's an x there. Negative 2x, got to divide by negative 2. And x is 1/2. All right. See, it's early release today, so I'm going to stop right there. We're at 23 minutes. I'll save the notes for tomorrow, so go ahead and put that away. Keep it in a safe place because I will mark it off.